Hello, class. So we are now in section 4.5, and this is actually the end of chapter 4. So this is about exponential and logarithmic equations. All right. So this will be, so along with being the last thing in chapter 4, this will be the last thing on your test 2 as well. Okay, so basically this whole chapter has been leading up to our original goal is we want to be able to solve equations, right? So we would like to be able to solve things like this, right? And this one is, easy enough that maybe if you look at it for a while and think about it, you could get the answer, right? X equals 2. One way that you could solve this is, though, if you know, right, like 5 and 25, they're related, right? So what you could do is match the bases, okay? So if you can match the bases, then because of one-to-one function things, which I won't get into, this implies the tops have to match, okay? So if you can match bases, then you can just look at the top and you're done. And this is the simplest way that we can solve exponential equations. So here, I have another exponential equation. This one is more complicated, right? You can't really stare at this and get the answer. But you know that 9 and 3, right? Those are related. In fact, right? 9 squared is actually 3 squared squared, right? Which we know our exponent rule. So this is 3 to the 4th, okay? And now we've matched our bases. So this means, since they're both 3's, this means the tops have to match. So you get 5x plus 1 equals 4. Right? Tops must match. And then that's a line, right? We know how to solve for that. So 5x equals 3. So x equals 3/5, right? And there you go. That's the answer. So this is good, right? This is a great first step. All right, but what happens when we run into this problem? Okay, what happens when I have 5x equal to 24? That's not 24. This is 24, right? Then we have a problem, right? Because there's no way to match, right? 24 isn't any power of 5. That's easy to know, right? So here is where we actually get into the point of this section, right? This secret step right here, you could think about it as me secretly doing log base 3 to both sides. Okay. And then right here, I log based 5 both sides. Okay. That's what this arrow is secretly doing that we don't talk about. Okay. But now I need to know that, because what I actually am going to do is I'm actually going to log base 5 both sides. Okay. And then what happens? Well, we know by the log properties, right? This should cancel, and then power rule. So technically the left-hand side just becomes x. And the right-hand side is the right-hand side, right? This is a number. So you are done. Okay? Now, if I'm asking you this on online homework or anything like that, they probably want a number. So that means I'm probably going to have to use the change of base formula, okay, because there is no log 5 button on a calculator, right? And then you actually plug it in and get like a number, okay? So like 1.975. Okay, but if this is on a test, then this is fine. All right, this answer is totally okay. In fact, you can really log any base you choose, like some of you might be wondering why I chose log base 5, the answer is because I get this nice canceling here to get x, right? And that's why I would log base 3 this one, okay? But, for example, if you don't want to be fancy, you can just always choose to natural log everything, okay? So this is the same problem, right? If I natural log both sides, well, then I have to power rule here to get the x in the bottom, okay? But then, right, and then hopefully here is the moment in time where you guys' algebra skills have improved enough that you can kind of just move things around even though they look weird. Because I'm going to just divide both sides by natural log 5 now. And we see that we get the answer x equals natural log 24 divided by natural log 5, which is the same thing, right? It's 1.975, okay? So you can get different looking answers that are the same, right? Just because of the way you solve it with logs, okay? So now let's do some more examples. Okay, so here I have 3x plus 2 equals 7. All right, again, I have many options. I'm going to solve this twice, actually. Okay, so option 1, okay, is I'm going to natural log both sides. Okay, because this is the like simple way. Okay, so if I natural log both sides, then I'm going to power rule this. Okay, and make sure I put my parentheses. Okay. You don't need these if you don't want. But definitely you do need these parentheses. Because then you have to distribute, okay? So x natural log 3 plus 2 natural log 3 equals natural log 7. Then solve for x. So, right, this is a line. It doesn't look like a line, but trust me, it is. And then ta-da, you get the answer. Natural log 7 minus 2 natural log 3 divided by natural log 3. Okay? And then, just to show you, this is actually the same, right, with power rule. I actually could have done this at any time. These are the same answers, okay? But yeah, this is one way to do it. All right. The fancy way would be, though, if I chose to not natural log, if I had chosen to log base 3 both sides. That is personally what I would have done, okay? Because if you log base 3 both sides, then this kind of just cancels and you get x plus 2 equals log base 3 of 7, and then you minus the 2 over. So negative 2 plus log base 3 of 7, and then you're done. Okay, so you can see one, I'm not saying the fancier way is better, because honestly, it's not really. If you're gonna need to use the change of base formula at the end anyway, right? Then it's not really that much better. But if you don't need to actually know what this number is, like with a decimal, then I do recommend this way. Okay. Now, though, when you get equations like this, then you should just natural log it because the base is e anyway, right? However, though, here is a very good example. Again, I'm going to solve it twice. All right, this is a really good example of waiting just to see what happens, okay? Maybe you should move something around before you immediately natural log both sides. So the first thing I'm going to do is immediately natural log both sides, because this is, it's not wrong. It's totally fine. All right, but then, right, I can't power rule, right, because the 8 is there. So I have to product rule right now and get this right? And then I get the nice canceling. So I get natural log 8 plus 2x plus 1 equals natural log 10. And then now I can solve, right? So 2x plus 1 equals natural log 10 minus natural log 8. 2x equals natural log 10 minus natural log 8 minus 1. X equals this thing. Ta-da! Right? And at any moment, again, I just want to emphasize, at any moment you could have done this if you really wanted to. And this will be the answer. That's fine. Okay. So what would I have advised though? My pro tip would have been don't immediately natural log. I would have said divide by 8 first to get this. Okay. Because then when you natural log both sides, this just automatically cancels and you don't need the product rule. You know, this is a number that we don't really care about. Oh, I could simplify. Let's go like 5/4, right? And then you can just solve this easily, right? 5/4 minus 1 divided by 2, and ta-da, you're done. Okay, and if we see they're actually the same, right? These are the same, right? Because I could simplify. 10/8 is 5/4. So again, many ways to solve this, not just one. All right, now, actually, something your book would like to assume you just automatically know how to do, okay, is they would like you to be able to solve this kind of equation. Okay, now this is a problem. Okay, and I want you to maybe pause the video and think, why is this harder than all the other examples I've done? Okay, so if you thought about it, if you look back, you'll notice something specific about all of these kind of questions. Okay, the very specific thing is they all only had 2 terms. This -6 is a big problem because, right, I can't natural log both sides because the 6 is going to mess up, something, and I can't power rule. Okay, so you're actually stuck. You do not log this. Okay, what instead your book just assumes is that you look at this and you realize that this is a quadratic equation. Okay, and it's probably more obvious if I do something like this. Okay, and then I tell you that u is equal to e to the x. Okay, because then, ta-da, it has reduced into a quadratic. Okay, so this is a reducible to quadratic, but now with exponential functions. Okay, but, right, we can factor this, right? X minus 3, well, u minus 3, u minus 2, plus 2, just kidding. Right, so then we get the 2 answers, u equals 3, u equals -2. Okay, but then we have to swap back. So e to the x equals 3, e to the x equals -2, and right, we solve these, right, these are easy. Natural log 3, natural log -2. Okay, and then hopefully you remember that actually, wait, right, that's not in the domain, right? You cannot have negatives inside natural log, so this is not an answer. This is the only answer. Okay, so that's a reducible to quadratic. Okay, so if you see any kind of exponential equation, with more than 2 terms, okay, you should probably just assume it's a reducible to quadratic, and you should plug in u equals e to the x, okay? All right, now, another last example for this kind of question is, I saw this once. This is a horrible trick question. All right, but this, okay, this one is interesting because there's x's on the bottom and the top, right? There's x's like polynomial looking ones, and then there's exponentials. Okay, and normally that's really bad. Okay, we would not be able to solve this, except if you notice, you can factor out the e to the x, right? Because they both just have e to the x. Okay, and then I'm gonna tell you this fact, okay, that e to the x is never 0. Okay, you technically should already know that fact because you've seen the graph, right? It has a horizontal asymptote here. But e to the x is never 0. So that means technically I can divide both sides by e to the x and just get here. And now it's just a polynomial that we know how to solve, right? Now it's just this. Did that wrong? Which implies x equals 0 and -3, and those are the answers. Okay, so if you see like polynomials and exponentials talking to each other, that probably means you can divide by e to the x and get rid of it. Like you can do some magical canceling is what I want to say. All right, but what I want to say, the main focus of this section would be this, the reducible to quadratic, and then like these. Can you just solve exponential equations when there's one on each side? Okay. So those two are important. Now we have to do the other half of the section. The other half of the section is, can you solve logarithmic equations? So if I give you this, can you solve it? Okay. And this isn't too bad. Okay, this one, because right, we know how to swap between exponentials and logs, right? So we know that 2 is the base, right? And then we swap the two things on the equal sign. So 2 to the 16 equals x. Ta-da! It just like solved itself. All right. But you should check, like here it's obvious, but check that 2 to the 16 is positive or in the domain. Here 2 to the 16 definitely is, because it's a really, really big number, like 5, 6 digits big. Okay. Now let's do another quick example. Okay, so if you have like natural log x equals 8, okay, you can again do the swap, right? So remember that natural log is just log base e. So that means the base is e, and I flip the things on the side of the equal sign, and ta-da, it just falls out. Okay. All right, so that's the easy way-ish to solve these. Now when you get slightly more complicated ones, so log base 2 of 5 minus x equaling 3, how do you solve this? Well, the answer is basically you do the opposite of what we did to solve exponential equations. So you notice here, I like log 3 to everything. Here, I am going to, quotation marks, I'm going to 2 everything. So what I mean by that is I'm going to raise everything to the power 2. Okay, or I'm gonna, it's technically called exponentiate both sides. Okay, but the reason I do this is because, right, inverse functions work both ways. So that cancels, and I actually just get 5 minus x here. And then here I just get 2 to the power 3. Okay. So this you can solve, right? 5 minus x equals 8. So x equals negative 3. Yes. Okay, and then recall, okay, I want you for every single log equation and exponential, well, not, yeah, no, just both, okay? You should check the domain. Is x equals negative 3 okay? If you check, right, negative 3, that gets you a positive number. All I care is that it's positive, okay? But in fact, it gets you 8, right? And then we know that this is 3. So it like works. But honestly, you just need to check, is this positive? Is it in the domain? Okay. All right, now let's do this kind of example. Okay, so if I can't in this problem, I should not, again, this is highly unrecommended, just automatically 10 both sides. Because remember, this is the common log, so it's base 10. All right, that's not advisable. What you should do is you should get the log completely by itself, the one with the x, okay? So what I'm actually gonna do is I'm gonna subtract both sides by 4, okay? And if I subtract both sides by 4, then I'm gonna get 9, okay? Then I'm gonna divide by 3, just because I don't even like the 3 being next to the log. I want it completely by itself. Then I get 3. And here is where I would 10 both sides. Okay. So then we get 2x plus 1 is equal to 10 to the power 3, which that is that's 1,000. Okay. So then subtract 1, divide by 2, and you get 999 divided by 2. And that's the answer. Okay. All right. Now, this is nice. All these examples have been a little bit on the easier side. So let me show you something that is more representative of what would be on like a test. Okay, so this problem is something more like what's on your study guide and your test and maybe final. Okay, something like this. Okay, because this requires a little bit more work than just moving stuff around. Okay, because of this 1, right? I can't really log 10. I mean, I can't really 10 both sides, okay? Because of this 1. What you have to do is, right, you need to get a log by itself on one side of the equal sign, but I have 2 logs. So what you have to do, okay, is you have to product rule, okay? And this is why, you know, the last section I taught you quotient rule, product rule, power rule, because you're going to need to be able to combine logs so that you can only get 1 on each side of the equal sign. So here I'm going to product rule, okay? And that means I get this technically, okay, equals 1. Then I'm going to 10 both sides. And I get x plus 2 minus x minus 1 equals 10. All right, and be careful, this is not a 0. Okay, you can't, like, the answer isn't negative 2 and 1. No, okay, you actually have to do work still. You get x squared plus x minus 2 equals 10. Then you subtract the 10 over. Okay, minus 12 equals 0. And now you refactor this thing. And and you get your answers, okay? So the answers are -4 and 3. But wait, again, but wait. Before you box them, are these in the domain? Okay, you check 3. 3 minus 1, that's okay. 3 plus 2, that's also fine. So this works. Is -4 in the domain? -4 minus 1 is -5. And remember, we can't have negatives inside of logs. So -4 is not in the domain. So the answer is x equals 3, okay? So again, I want to make it a kind of a big deal that you should check your answers, okay? Pretty important. So let's do one more like this, and then that'll pretty much be it for this section, I think. So here's another example: log base 9, x minus 5, plus log base 9, x plus 3, equals 1. Okay. So same thing. I'm gonna have to get one log here. So x minus 5, x plus 3 equals 1. Then the magic step of I'm going to 9 both sides, okay, because of the 9. So the right-hand side cancels, and it's just this thing, okay. The left-hand side is 9 to power 1. That's 9. Okay, and then now it's just a quadratic equation, which we should know how to solve. Okay, so it's this. X squared minus 2x 15 plus, wait, where'd I get this minus sign? Should not be there. Okay, yeah, 15 minus 9. Okay, there we go. 24. Okay. This once again does factor into this. So you get the answers x equals -4 and 6. If you look, -4 is definitely not in the domain. 6 almost wasn't either, right? 6 minus 5, that's 1. So that's really close, okay? It is possible, all right? It's possible that both of them work. It's possible that none of them work, okay? It's just that you do just have to check, okay? And so now let me see if I have an example actually where I can see that. So not really. Okay. Yeah, I'm gonna call this the end. Okay. Your test 2 is pretty huge. So I'm probably gonna make an announcement about like the focuses of it, because normally I would say guaranteed there's gonna be like one of these, okay, like a logarithmic equation and some kind of exponential equation. So maybe like this one or this one, okay? But because your test 2 just has so much sections in it, I don't want to guarantee that, okay? But that's it for chapter 4, all right? And then see you guys next class.